After defining the damping, let's move on to define other analysis settings. The first command os.wipe analysis clears all the previously defined analysis objects followed by vissue, constraints, numberer, system, etc. These commands are required for nonlinear time history analysis. We use the newmark integrator with a gamma value of 0.5 and a beta value of 0.25. That's it. With that, we are done with the analysis setup and we are good for performing the earthquake analysis. The analysis is performed using the command called os.analyze. This command takes two inputs, the number of steps that needs to be analyzed and the time step between two consecutive acceleration steps. This analyze command returns 0 if the analysis is successful, else it returns some non-zero value. In the end, I additionally printed the current time in the domain and the applied time for cross verification if the analysis is completely performed or not. If the analysis is completely performed, then the current time in the domain t current and the total applied time will be same. Now let's post process the results obtained from the analysis. Specifically, we will be exploring how to load and visualize the displacement and the reaction force data obtained from the simulation. If the analysis is successful, the displacement and reaction force files will have complete data. Else, some data will be missed at the end in both of the files. This missing data will create some errors while loading the files using load.txt command. Hence, I used a try except here. If the load text generates a value error, then we use another command of numpy called gen from txt, where we give some additional parameters to skip the last two lines in the file. As I said before, if the analysis is successful, we have complete data and the lengths of the displacement and reaction force vectors will be same. If the analysis is unsuccessful, the lengths of the displacement and reaction force vectors are different and we cannot plot two vectors of different lengths. Hence, for plotting, I consider the minimum value between the number of steps in the displacement vector and the base reaction vector. Let's run the analysis for one more time. As we can see here, the gravity analysis is successfully run and also the seismic analysis is successfully run. The time that we solved is some 40 seconds and the time that we applied is also 40 seconds. It means the analysis is completely performed. Let's see the results of displacement time history and reaction force. This is the plot between the base reaction and the displacement, and this is the plot between the time and the displacement values. The maximum displacement that we have obtained from this analysis is minus 5.8511 mm occurred at 6.525 seconds. Next, let's perform the analysis for other two ground motions, that is Imperial Valley ground motion at Chihuahua and the Loma Prieta event. The time step for Imperial Valley ground motion at Chihuahua is 0.01 and the number of steps will be automatically extracted from the file. Let's run this. If you look at this, analysis is also completely performed. The total time in the domain is approximately 51.59 and the total applied time is 51.59. So they both are equal. The maximum displacement that we have obtained from this earthquake is minus 80.132 occurred at 13.86, and this is how the cyclic load and displacement response between the displacement at the free node and the base reaction looks like this. And for the Loma Prieta event, the time step is 0.005. When we run this, it can be seen that the total time in the domain and the total applied time are almost same. It means the analysis is fully completed. If we look at the plots, this is how the displacement versus base reaction looks, and this is how the displacement time history plot looks. The maximum displacement occurred at 14.845 seconds and the value is 104.532 mm. The earthquake analysis presented in this tutorial is successfully ran without any issues, but many analysis will not be completed successfully in one go. It is very common to encounter convergence difficulties when trying to simulate earthquakes accurately. In the next video, we will demonstrate a popular technique that can help us overcome this convergence issue. You can download this source file using the link provided in the description. Using this source code, you can analyze a variety of RC columns under a variety of ground motions. You can download the ground motions from peer ground motion database for free. If you have any questions or suggestions, we recommend you to please write them in the comment section below the video. We greatly appreciate your feedback and we will do our best to respond to each and every comment. If you like our content, please hit the like button and subscribe to our channel. Happy learning. Thank you.